So we're waiting for Clive Wright, who's Vice President of Engineering at Saturna Green Systems here in Vancouver, and not quite sure where he is, but we're on a schedule here. We're hoping he shows up soon, and there he is. Welcome to the Drive for Innovation, Clive.
Thank you. Good to meet you.
This is the V-Moto scooter.
Yes.
And this isn't your technology, but what's behind it?
Yes, what's on the screen is very much what Saturna's doing. We have really two parts of the system. There's a screen element, which is the most visible, which you can see here, and that's replacing the dashboard that would normally be on this scooter, which is normally a regular analog dashboard with a two-line display. And it doesn't tell you very much. It tells you, well, mostly it tells you full, empty,
Right.
which is a bit of a problem. And that's one of the problems we're trying to solve here. And then behind it is another system, which is more of a microprocessor, GPS, GSM modem, and all those elements. And that's actually further down in the body of the scooter. But it talks to this display, forming a whole system.
Talk a little bit about its functionality.
Yes, so that's one of the main things we bring is many elements to prediction of range, just as an example. And that's an area of great anxiety for people purchasing fully 100% electric vehicles, is they don't know how far this thing's going to go. But how far it goes is really dependent on more than just battery. Obviously accurate battery state of charge estimation is a key part of that. But well beyond that, how hilly the surrounding area is, the driving style of the particular driver. Some drivers are more aggressive, some are less aggressive. The temperature, many factors that actually make a significant difference. The age of the battery. These all bear down on how far the scooter can go.
Let's talk about some of the engineering challenges that you've confronted when you've done this. First off, I look at this, in the daylight, you have to deal with glare.
Yes, the screen in fact is one of the most difficult pieces engineering-wise to have dealt with. You've got to deal with direct sunlight, you've got to deal with reflections, you've got to deal with rain falling onto the touchscreen. It's a touchscreen interface, which is what most people expect these days. Raindrops actually activate most touchscreens. You've got to deal with extremes of temperature. This thing, and though many people won't actually ride an electric scooter in minus 20 Celsius, or Fahrenheit for that matter. But we do need to be able to operate in a very large range of temperatures. We need to be able to operate with people who are wearing gloves and things of that nature. So we've got a lot of challenges on the screen side in particular.
So it's resistive.
Yeah, we're looking at both, we've actually looked at both technologies.
Yep.
There are some capacitive technologies now that will actually work with gloves, and that there are some software algorithms that you can use to eliminate raindrops as a source of interference. So we're actually experimenting with both, but resistive is the obvious solution.
So walk us through the guts of the system. You're using ARM processor, Intel?
Yeah, we're using an ARM-based processor. It's a fairly high-spec processor. Processors now are relatively cheap for the amount of functionality and the amount of horsepower that you can get. And what we felt particularly was that there's a market here for use of this technology with fleets and corporations. And one of the things that fleets and corporations would like to do with these vehicles is customize what's on the display, add apps, add notifications. So for scooter rental, for couriers and dispatch, for scooter sharing schemes, many different places that you could take this technology. We don't want to build all of that, so we've decided that what we want to do is build a platform. So to that end, we've chosen a processor that is capable of running a version of Android, and we're making a special version of Android, a cut-down version, that does what we want and adds the APIs we want to allow those features.
How has this particular project challenged you personally as an engineer?
Personally as an engineer, my hardware skills were a little rusty when I came into this. I last designed hardware in the late 80s in the UK, and in fact when I moved to Canada some 20 years ago, that's when I started at Motorola and mostly by then was on the software side. So it's been really interesting brushing off the rust from my hardware knowledge with the very good help of my director of hardware engineering, who's been tremendous help in this. So I'm taking more of a systemic view, end-to-end, hardware, software, everything from embedded all the way through to the APIs and the cloud side of it. But I'm also getting highly involved in the hardware, which is very exciting for me.